Let's continue section 4.3 on quadratic functions and their properties. We were looking at two different ways to graph a quadratic function. The first way was using transformations. So in example 1 and example 2, we saw how we could complete the square. A little different strategy for doing that because we're working all on one side of the equal sign. But we complete the square and then we can see those transformations. We can also identify the vertex and the axis of symmetry. In example 2, we failed to answer. Does that one open up or down? And of course A equals -3, so it would open down, a negative, right? So let's move on now to the second method of graphing. And in this method, the first thing we do is determine which way the direction of opening. Then we determine the vertex using this little formula. For the x-coordinate of the vertex, it's -b over 2a. Now that should sound familiar. Think about the quadratic formula. -b plus or minus square root of b squared all over 2a. So this is everything but that the radical and the discriminant, right? It's the -b over 2a. Then whatever you get for x, you plug it in to get the y-coordinate of the vertex, and then you know your axis of symmetry is always x equals the x-coordinate of the vertex. And here's something then that we know based on the discriminant. We have looked at the discriminant before to determine how many solutions we expect. In this case, now we're looking for how many intercepts, because the solutions of a quadratic are the same thing as the solutions to this function are the intercepts, the x-intercepts. So we can determine the y-intercept. You just let x equal 0, right? Just plug in 0 for x and determine your y-intercept. For the x-intercept, first, we'll look at what b squared minus 4ac is. If it's a positive number, then the graph of the quadratic function has two distinct, meaning different, x-intercepts, which are found by solving this equation. We'll set it equal to 0 and find those two distinct x-intercepts. If, however, b squared minus 4ac equals 0, then it has one x-intercept. So how does it intercept just once? How does a parabola intercept the x-axis just once? Well, it touches the x-axis at its vertex. The vertex is sitting on the x-axis, so it only intercepts once. And if b squared minus 4ac is negative, there are no x-intercepts. We don't have any imaginary points on our graph. So, step 4 will mean we will determine the additional point using the y-intercept. Now we're graphing, right? So we've got, at this point, what do we have? We have the vertex. We know the axis of symmetry. And we know our x-intercepts, and we know our y-intercept. And then we can use that y-intercept and the axis of symmetry to find a matching point using symmetry to do that. And then we'll draw our graph. So let's practice that. In example 3, we're given this quadratic function, and there's many things we want to determine from this quadratic function. First, whether it opens up or down. Which is it? Well, a is -2. A is -2, so it opens down, right? All right, now we want to find the vertex. So here's how we find the vertex. We said x is going to be equal to -b over 2a. So b is 12, so it's -12 over 2 times. We said a is -2. So -12 over -4. So 3 is the x-coordinate of the vertex. To find the y-coordinate of the vertex, we plug in the x-coordinate of the vertex. What is f of 3? And let's see, what did I get? I got 2. Okay, so we know that the vertex is the point 3, 2. All right, so we found the direction of opening. We found the vertex, the axis of symmetry. The axis of symmetry is a vertical line, so it has the equation x equals, and it always equals the x-coordinate of the vertex. So you already have it, you just have to write that. Okay, now we're to find the y-intercept. So to find the y-intercept, let x equals 0. And of course, that's just negative 16. So the y-intercept is 0, negative 16. And now, before we find x-intercepts, let's make sure we have some. Let's analyze b squared minus 4ac and find out, are we looking for 2, 1, or none? b is 12 minus 4 times a times c, and you get 144, and this comes out to be a negative, and you end up with 4. So b squared minus 4ac is equal to 4. So we're looking for 2 different, distinct x-intercepts. So let's find them. We find them by setting negative 2x squared plus 12x minus 16 equal to 0 and solving. Now all three of those terms are divisible by negative 2, so I'm going to do that first to make it easier, because this will factor now nicely. It would have factored before, but a lot easier now. So what, negative 4 and negative 2, so x equals 4 and x equals 2. So we have our two distinct x-intercepts, 4, 0 and 2, 0. All right, let's start graphing. Our vertex, we said, is 3, 2. 3, 2. Our axis of symmetry, I like to use a dotted line to show that. This is my line that divides my parabola into two symmetrical pieces, x equals 3. I know I cross the y-axis at 0, negative 16. I'm not going to be able to plot that point, unfortunately. And I know I have x-intercepts at 4, 0, and 2, 0. So I may have to find another point here to be able to draw a nice graph. But if I could plot my y-intercept down here, then I could find a matching point symmetrically opposed over here on the other side. That's what they mean by using the y-intercept and the axis of symmetry. Okay, we've done that. And so let's see. I know I don't touch the y-axis till I get beyond this graph, so I just do something like that. And state the domain. What's the domain of this function? Of course, it's all real numbers. The range, low to high. How low do we go? Negative infinity. How high do we go? Looks like we go all the way up to 2. Do we get to 2? Yes, that point is on our graph. Now it asks for increasing and decreasing intervals, and all of these in interval notation. What do they mean by that? Well, we've seen that. We've talked about increasing graphs. The graph is increasing if, as x goes up, y goes up. But with a parabola, there's a change point at the vertex, right? So we have a part that's increasing and a part that's decreasing, and it just depends on if it opens up or down and what those intervals are. So I'm going to write increasing and decreasing, and then I'll figure out where these intervals are. Now, what I'm going to refer to here are x values. What x values make y go up? Well, as we come from negative infinity to 3, each unit I move this way, my y keeps going up, right? Until I get here. So from negative infinity to 3, my y values are increasing. Now at 3, we're not increasing or decreasing, so that's an open interval. Now as I leave off from 3 and keep increasing, x keeps increasing, what's happening to y now? It's decreasing. So starting at 3 and going to positive infinity, my y values are decreasing. So the thing to understand here is these are my x values. Make a note, you're not talking about y, you're talking about x. Which x makes y go up? What x's make y go down? Okay, that's the thing to keep in mind.